We will now discuss the JSF lifecycle. The JSF framework defines a lifecycle that executes in 6 distinct phases. The first being the restore view phase, followed by apply request values, process validations, update model values, invoke application, and then finally render response. The lifecycle has 2 logical portions, execute and render. It supports Ajax partial processing and partial rendering, and you can specify components that JSF processes on the server or that JSF renders when an Ajax call returns. Here is a complete diagram of the JSF lifecycle, and it's very important to understand the lifecycle so that we can understand the inner workings of JSF. So let's go ahead and look at each of these 6 phases in greater detail. The first phase is the restore view phase, which will restore an existing view from the previous request or create a new view for an initial request. The resulting view is then put into the current phases context. We'll start the lifecycle and the restore view phase will be called. The first subphase is for Phaselets to parse the page description language, our markup. JSF will then build the component tree on the server. Now we can see a one-to-one relationship with many of the tags in our markup and in the component tree, which contains our live Java class instances. This phase will also save the view in a Phases context instance, making it possible to repopulate the page if necessary. So for example, perhaps the user does not fill out a form as required. The second phase is the apply request values phase and is where submitted request parameters are mapped to their corresponding UI input components. When the user submits a form, all values are passed as strings in the request parameter map. The apply request values phase is where we extract this value and set the submitted value on the component. Now keep in mind that the submitted value is not the same as the model value, which will be set in the update models value phase. The third phase is the process validations phase and is where submitted values are processed by JSF converters and validators. The main purpose of conversion and validation is to ensure that all values have been properly sanitized before updating our model data. So if any component fails validation, then the component's valid property is set to false and a Phases message is added to the Phases context. If conversion and validation passes, then the fourth phase, the update model values phase, is reached. If expression language value bindings were specified on UI input components, then those component values are set in the model. So for example, the following expression language value binding, here we have an H input text with a value binding to the property first name on mybean, and this will cause the setter for first name to be called, and it's going to be passed the result of the HTML input text get value. The fifth phase is the invoke application phase and is where methods in manage beans that perform some kind of action are called. So in this case, we've updated our model values and we can then call our actions and action listeners, which contain our business logic. So action listener methods are called first and then actions. Finally, the sixth and final phase is the render response phase and is responsible for invoking component renderers for the appropriate client device, sending a fully encoded response back to the client, and the response is typically HTML markup that is written to the HTTP servlet response output stream. Now the lifecycle will not always call each of these 6 phases. In the HTTP GET scenario, which is done the first time a page is requested, a Phases request is generated by the browser, sent to the server, and the Faces servlet will start the JSF lifecycle. The Facelet view markup will be parsed by our Facelets view handler, and the component tree will be built on the server. We're then going to transition right to the render response phase, where the process renderer subphase commands the component tree to render itself as per the target client device, which in the majority of cases is a web browser. There then may be some state to save, and we render the response back to the client. Now, in the case of a postback, the lifecycle behaves in a slightly different manner and depends on whether valid or invalid values are submitted. So let's take a look at valid values first. Our first phase is the restore view phase, where we build the component tree, apply any save state, and then we transition to the right to apply request values, where we extract the submitted values. We then apply any converters or validators in the process validations phase, and since we're operating on valid values, conversion and validation will be successful, and we're then going to update our model bean values. We're then going to invoke any actions or action listeners on those bean values, and then we're going to render the response back to the client. Now, in the case of invalid values, the lifecycle behaves slightly different. Again, we have our restore view phase followed by apply request values, but in process validations, a validator or a converter has failed, so we have an invalid value. Now, we definitely do not want to update our model values with incorrect or invalid data, and we definitely don't want our application methods, actions and action listeners, to operate on that invalid data. So the process validations phase will create a faces message, add that to the faces context indicating an invalid value, and we're going to transition directly to the render response phase, and of course render a response back to the client indicating a converter or validator issue. Now, JSF2 has modified the lifecycle. It's added a request method on the client, and this method posts the request back into the JSF lifecycle. So upon entering the lifecycle, the Ajax request state is captured via the partial view context, and this object provides access to information such as which components are targeted for processing and or rendering. The process partial method in the partial view context performs partial subtree processing and rendering. The callback provided by the request method is invoked when the rendered response is sent back to the client, and this callback automatically updates the client-side DOM to reflect the newly rendered markup. So to encourage compatibility across JSF components and frameworks, the request and response payloads have been standardized. And that concludes our lecture on the JSF lifecycle. Our next lecture is on JSF Phaselisteners. A phase listener is an interface implemented on a Java class that is registered with the JSF application. Most importantly, phase listeners provide hooks into the JSF lifecycle and can be extremely helpful for application customization, optimization, and debugging. They can listen to all phases of the lifecycle or only to specific phases. The listener can be deployed application-wide with an entry in our Faces config file or on a per-page basis with the Phaselistener tag. Phase listeners are executed on every JSF request and can be used instead of a filter or a servlet without requiring user configuration, since they are pluggable. An example usage of a phase listener is to check user permissions before processing the JSF lifecycle. But keep in mind that they do add overhead to lifecycle processing, so keep them brief and to the point, and invoke them only when necessary. In order to implement an application-wide phase listener, we must implement the phase listener interface, And we're going to use the phase ID to specify which phase to listen for. We're then going to register the implementing class in our phases config file like so. Here we have a phase listener called logging phase listener. To add a phase listener on a per page basis, we're still going to create and implement a listener as normal, but instead of adding an entry into our phases config, we're going to use the Phaselistener tag in our page. So here we have the Phaselistener tag, and we have our page phase listener. JSF will register the Phaselistener instance on the UI view route in which this tag is nested. And that concludes our lecture on JSF phase listeners. Our next exercise will be on JSF phase listeners. The goal of this exercise is to add a phase listener to the job application project. And this phase listener will simply log the phase ID to the Tomcat console log before and after the phases execute. And this will let us examine various different scenarios within the JSF lifecycle. Our first step is to create our phase listener. So we're going to create a new class called logging phase listener in the org ICEfaces training applicant lifecycle package. And we're going to add an interface. So we're going to add a Ajax faces event phase listener interface. So let's go to our IDE and expand Java resources. And we're going to right click on source and select new class. To save us some time, we're going to browse for a base package name. So I'm going to choose org ICEfaces training applicant. And I'm just going to append lifecycle. The name of our class is going to be logging phase listener. And I'm going to select the add interface button and type in phase listener. And we only have one result returned, and that's the correct one, Ajax faces event phase listener. And then I'll select finish. We're now going to add the code that will output our phase ID for both the before and after phases of each phase. And most importantly, we have our getPhaseID method, which is returning a value called anyPhase. Now, this is how we specify that we want this phase listener to execute for every phase in the JSF lifecycle. So let's grab this code and we're going to overwrite our stubbed methods. So we'll overwrite. Now, instead of this phase listener executing for all phases in the life cycle, in the getPhaseID method and in the phaseID constants, we could choose from any of the 6 phases of the life cycle. But in this case, we want all phases, so we'll choose any phase. Step 3 is to paste our XML fragment into our phases config file. Again, this is going to be an application-wide phase listener. And this XML fragment will cause the logging phase listener class to be registered as a phase listener when the JSF framework initializes. So we'll copy this fragment here, and we're going to go to the phases config file here in webinf. So we'll choose phases config and then source, and right below the application node we'll add our phase listener definition. Step 4 is to now run our application. So we'll start our server and we'll navigate to job application/job-applicant.jsf. And we're going to examine the Tomcat console log for our phase listener output. And we're going to see that only the restore view and render response phases took place. So let's go back to Eclipse, and I'm going to expand the bottom portion of my IDE. So we'll start my server. We're going to navigate to our application. Now again, in our Tomcat console, we see that only the restore view and render response phases are logged. Now remembering back to our lecture on JSF Lifecycle, this is our initial HTTP GET scenario. So our phases request comes in and we start the JSF Lifecycle, and we parse our page description language, we build our component tree, but again, this is our initial page request. So we're not going to execute other phases of the life cycle. So in the case of a postback, we're simply going to build our component tree in the restore view and then transition directly to the render response phase and serve this page to the user. Now let's type a value for the first name field and click submit. So again, referring back to our lecture on the JSF lifecycle, this will be the scenario whereby we submit invalid values. So let's examine the Tomcat console for that scenario, and then let's enter in valid values for all fields and click submit, and then examine what happens there. So we'll clear our console output, and let's then just enter in a first name. And well, we have various validation errors. So looking at our console output, we can see that, well, we have the restore view phase, we apply our request values, and then we process validations. But here, our converters or validators have marked a value as invalid. So again, we have our missing required fields and a validation error. So instead of updating our model bean values and invoking our application methods, we're going to transition from the process validations phase directly to the render response. And we'll create a faces message, attach that to the faces context, and that's essentially what we see here. So we have our validation errors. Now let's submit valid values for all fields. And then submit applicant. And now we can see, well, we have the restore view phase followed by apply request values, process validations, and there aren't any conversion or validation issues. So then we're going to update our model bean values, invoke any application methods, and in this case it's our submit method, and finally render the response back to the client. So referring back to our lecture on the JSF lifecycle, this is the case of a postback with valid values. Now this phase listener will execute and generate output to the console on every faces request. So we're going to comment out the phase listener for the time being. And to do that, we're going to add the following. Let's come back to our phase listener, and we're going to add an opening bracket exclamation point dash dash, and then to close it off we'll have a dash dash closing bracket. And now our phase listener is no longer active. And that concludes our exercise on adding a application-wide JSF phase listener. Our next lecture is on JSF Validators. JSF utilizes validators to ensure that user input matches criteria specified by the developer. This can be achieved through one of 4 ways: by using the 6 standard built-in JSF2 validators, by adding the required attribute on the components themselves, by using interdependent validation in the backing bean, or by creating a custom validator either in a class or as a bean method. JSF provides 6 built-in validators, so for example we could use the validate double range, validate long range, validate length, validate bean, validate regular expression, or validate required functionalities. JSF validators can be added to a tag in one of 2 ways. First, as an inline attribute. So here we have an input text with a value binding to a property travel percentage. And we've also specified a validator attribute, which corresponds to a validator called travel validator. We can also add a JSF validator as a child component. So in this example, we have an input text, but nested within it is an f:"validate long range tag with a minimum and maximum value. So this tag is going to restrict user input between the values of 0 and 100. Now, by using the required attribute, JSF can ensure that an input field is populated by the user. We can set the required attribute to either true or false, and is quite easy to use. In this example, we have an input text with a value binding to a property first name, and all we've done to ensure that a user enters in a first name value is to set required to true. Validation is performed as a part of the JSF lifecycle in a phase called process validations. We'll discuss the lifecycle in greater detail in a later lecture. If validation fails, JSF is going to generate an error message that can be displayed on our page. Validation error messages are displayed using the hMessage tag. So for example, here we have an h input text with an ID of first name. Below that we have an hMessage tag with a for attribute corresponding to the ID of our first name input text. Most importantly, we have required set to true. So if a user does not enter in a first name value, an error message is going to be output through our hMessage tag. Interdependent validation is when there are 2 or more fields, and a combination of values selected between these fields could cause a validation error. So this is validation done at the backing bean level. So for example, perhaps we have validation logic that may require a user ID to correspond to their country. Now in the submission method in the bean, we would go ahead and compare these 2 fields. If they fail to validate, this method will manually add a custom error message that will be displayed in our page. Now, creating a custom validator is useful if we need to check input in a way not provided by the standard validators. So for example, we could create a country validator, a username uniqueness validator, or possibly an email format validator. Let's now step through the process of creating a custom validator. Our first step is to create a class that implements the validator interface. We would then implement the validate method with our custom logic. So in this case, we're creating a custom validator called unique user validator. Our second step is to register this validator with the JSF framework by either using an annotation or by specifying it in our Faces config file. By specifying as an annotation, we would add the @Faces validator with the validator ID by specifying value equals unique user validator. Alternatively, we could register this validator by placing an entry into our Faces config file. Here we have a validator tag with a validator ID, again called unique user validator, and the subsequent class. Step 3 is to use the validator in our page. So here we have an H input text, and nested within this tag is an F validator tag with a validator ID that corresponds to our custom validator, unique user validator. Now, validation can be done directly in a bean instead of creating a separate class. So for example, here we have an H input text and a validator attribute that corresponds to a method called country validate. In our bean, we would then implement the country validate method. Normally, a custom validator class is used instead of this because it encapsulates validation in a reusable class. And that concludes our lecture on JSF Validators. Our next exercise is on JSF Validators. The goal of this exercise is to add form validation to our job application project. Step 1 is, in order to make our fields required for validation purposes, the required attribute needs to be set. In jobapplicant.xhtml, we're going to add required equals true to our existing input and select components. So let's now go to our IDE, and in order to ensure that a user enters in values for all form fields, we're going to set required equals true. I'm then just going to copy this and paste it for our remaining select and input components. So for first name, last name, the select one menu for country, and finally the input text for salary. Step 2 is to add our H message tags. When the user clicks the Submit Applicant button, validation will fail if nothing has been input or selected on a component with required equals true. When validation fails, JSF will generate an error message that can be displayed with the H message component. So what we're going to do is that in jobapplicant.xhtml, we're going to add an H message tag after each input and select component. Now the value of the for attribute of the H message component must be the same as the ID attribute of our H input text component. And finally, what we're going to do is create another column for our validation messages by changing the H panel grid columns attribute to 3. So let's go back now to our IDE, and we're going to add a H message tag for each of our input and select components. So we'll add an H message tag for title, and we'll do this for the rest of our components. So we'll add one that corresponds to first name, one for last name, one for country, and then finally an H message tag for salary. And then our last step is to change our H panel grid number of columns to 3. Because now we have our H messaged components as well. Step 3 is to add a JSF standard validator, the fValidate long range tag. In job applicant, we're going to nest this tag in our salary H input text component. And the fValidate long range tag is going to constrain the value between 1 and 1 million for our salary field. So we'll copy this code, and we're going to go back to our IDE into job applicant, and I'm just going to scroll down. So we had previously added a standard JSF converter, the fConvertNumber component. We're now going to add the fValidate long range component. Step 4 is to now add our interdependent field validation action listener. So we're going to paste the following code into jobapplicant.java, and this code is going to cause an interdependent field validation error when the user enters John as the first name and Doe as the last name. So looking at the code, we can see if first name equals John and last name equals Doe, we're going to create a custom message. John Doe already works for us. We're then going to pass that message into a new Faces message instance. We're then going to get a current instance of the Faces context. We're going to set string client ID to null because this is going to be a global message, which we'll talk about shortly. And then finally, we'll pass this null client ID and Faces message into the Faces context so that it's rendered to the user. So we'll copy this action listener method. And we're now going to go into our Java resources source and then into our model package, into jobapplicant.java. And we can just paste this here below salary. And I'll quickly format doing Control-Shift-F. And then what we can also do is do a Control-Shift-O to resolve any missing imports. So in this case, Eclipse isn't quite sure what to import, but we always want to make sure we import the Ajax faces event action event. And Eclipse is able to figure out the rest for us. We're now going to bind this method to our command button. So what we're going to do is we're going to add a new action listener attribute, which again is going to be bound to the job applicant submit method. So essentially when this button is clicked, we're going to fire the submit method. So let's copy the action listener and let's go to jobapplicant.xhtml and let's paste this within our command button code down at the bottom here. Step 6 is to add our global messages component. So we're going to add an hMessages plural component with global only set to true. Now, when global only is set to true, this will cause all messages for the current page with a null client ID to render to the page. So 2 slides ago, when we were reviewing our submit method, we were setting the client ID to null for our faces message for John Doe already works for us. So in this case, we're setting global only to true, so all messages with a null client ID will render out through this hMessages component, which we're going to place directly after the opening hForm component. I'm just going to copy, and then at the very top of jobapplicant.xhtml, I'm just going to drop this in below our opening hForm tag. I'll just format that. And now finally, we can run the application. So our first test is to enter in a title of Mr., a first name John, but we're going to leave last name and country blank. We're also going to only enter in a value of 0 for salary. So what we're going to see is inline error messages to the right of last name, country, and salary. But last name and country are required values, so they're going to fail validation. But salary is going to fail conversion because we don't have the $ symbol. So let's start our application server. Start Tomcat 7. And let's navigate to our application. So localhost 8080 job application / job -applicant.jsf. We're going to select Mr. and first name John, last name blank, country blank, and salary simply 0. And then we'll submit our applicant. So we can see that to the right we have 2 validation errors because the value is required. And then for salary, we have another validation error here because 0 could not be understood as a currency value. And an example is $99. Now our next test is to enter in the last name Doe, a country United States, and a salary of $0. Again, we have the dollar symbol present. We're then going to see an inline error message next to the salary field failing validation. Again, because our fValidate long range tag constrains our value between 1 and 1 million. So let's go back and enter in a last name of Doe and a country of United States. And then let's add a $sign. So again, we see that we have a validation error. The specified attribute is not between the expected values of 1 and 1 million. And our next step is just to add in a valid value. So we'll input 100,000. And we can then submit our applicant. Now we no longer have any validation errors, so we reach our submit method, but we've entered in John as the first name and Doe as the last name. So now our interdependent field validation within our submit method has fired, and the corresponding faces message has been output through our global hMessages tag. And we can then enter in a different last name, and this condition will no longer happen. So we no longer have any validation error messages. And that concludes our exercise on JSF validators. We're now going to create a custom JSF validator. The goal of this exercise is to validate an email address input using a custom validator. Step 1 is to create a validator class. We're going to create a class name called Email Validator. It's going to reside in the Validators package, and we're also going to add the Ajax Faces Validator interface. So let's go to our IDE, and we're going to right-click on our source package. And we're going to select New Java class, and we're going to call it Email Validator. We're then going to select a package name, a base package name, by clicking Browse and selecting org ICEfaces training applicant.view. And then we're just going to append validators. And we also need to implement the validator interface. So I'm going to click the Add button and then type in validator. And I want to select the Ajax Faces validator. So I'll select OK. And then I'll select Finish. So now I've created a class called Email Validator that implements the Ajax Faces validator interface. And we also have our stubbed validate method. Step 2 is to annotate our class. So we're going to add the @FacesValidator annotation to this class. And this is going to register the validator with JSF under the name Email Validator. So I'm going to copy this annotation and navigate back to our IDE and back to our Email Validator class. And just place this above the class name, the annotation. And to resolve the missing import, I'm going to hover over Faces Validator and then import Ajax Faces Validator. Step 3 is to now implement the validate method. So we're just going to copy and paste this code and replace the existing validate method in our Email Validator class. We're not going to concern ourselves with the logic in this method. We're simply going to copy and paste. But it's essentially going to validate an email address for us to ensure it's of the correct format. Okay, so again, I'm going to hit Control-Shift-O to add our missing imports. So we're going to import the Java util regular expression pattern. Similar, the Java util regular expression matcher. And then Eclipse will take care of the rest for us. So if the email is not of the correct format, we're going to create an invalid email message and display that to the user. Step 4 is to add an email field to our page. So we're going to add an email component with an associated output label and message tag to our page after the last name component. And we can see that the email validator, our custom validator, is registered using the validator attribute of our email input text. I'm going to copy this code and place it below our last name component in jobapplicant.xhtml. So scroll down and find our last name field and place that directly below. Step 5 is to add a corresponding bean property. So we're going to add the string email property to jobapplicant.java and also generate the getters and setters. So let's find job applicant, which resides under source, our model package, job applicant. And we're then going to add a private string email. And we'll just hover over email and we'll see our tooltip and we can select create getter and setter for email. And we can just select OK. Step 6 is to now run the application. So we'll start our server and then we're going to enter in random characters into the email field. We will submit the form and the email validator registered with the component will output the specified error message via the message tag. We're then going to enter a valid email address, submit the form, and the field passes validation. So our first step is to start Tomcat 7, or perhaps restart to ensure that all changes have been pushed across to your WAR file. And we're then going to bring up our application. So localhost 8080 are the default settings. Job application / job-applicant.jsf. And we now have our email field. And so I can enter in some random characters and hit submit. And we can see that we have our custom error message thrown by our custom validator, indicating that this is an invalid email. I can then add the @ symbol followed by a .com address and click submit applicant, and we can see that the custom validator error message no longer appears since the email is now valid. And that concludes our exercise on creating a custom JSF validator. Our next lecture is on the JSF converters. The main purpose of conversion is to ensure that our values have been properly sanitized before updating our model data. JSF uses converters to modify input and format output, and possible conversion options include implicit or explicit conversion of data types. We can use the standard convertDateTime and convertNumber tags, or we could also create a custom converter. JSF can implicitly convert bound values to the proper data type. So when a form is submit, all fields are submit in the request parameter map as a data type string. And what JSF will do is automatically convert that to the correct data type. So in this case, we have an instance variable age, and in the backing bean, it's of data type int. So instead of requiring a string data type, JSF can handle the int age automatically. Explicit converters can be added in one of two ways: as an inline attribute using the converter attribute, or as a child component. So here we have an fConverter tag nested within an input text component. The child component is typically considered more readable markup and can expose configurable attributes. Here's an example of explicit conversion. We have an input text with the converter attribute of data type integer. But in our backing bean, we have age as a data type string. Now in this case, we require an integer data type on the page, but we're going to store it as a string in our backing bean. The fConvertDateTime tag is used for both input and output and is bound to a Java util date. We can use this tag to customize the date and time appearance with the following attributes: the date style which defines the date verbosity such as default, short, medium, long, or full; time style, which defines the time verbosity; the locale, which is useful for internationalization; and a pattern, which uses the Java text simple date format. So an example of a pattern is the 2-digit month, 2-digit day, and a 4-digit year. The convert number tag is used to output numbers, currency, decimal formatting, among others, and it enables customization of the number appearance with the following attributes: type, which defines the overall format and parsing; the grouping use, which defines if grouping separators should be added; a max and min fraction digits; and also a pattern, which is similar to the Java text number format. To use the fConvertDateTime tag, we would nest it within an input text component or as a child of that component, and we have three attributes set. It's of type date, we've defined a time zone, and we've specified a date pattern. The fConvertNumber tag can also be nested as a child of a component, in this case an input text, and is of type currency. We've specified the grouping used to be true. We've entered max and min integer digits, and we've specified a currency code. Creating a custom converter is useful if we need to format input or output to match specific business logic. For example, we could create a social security or phone or credit card custom converters. And we're going to step through the process of creating a custom converter next, followed by an exercise where we implement a custom converter in our application. The first step in creating a custom converter is to create a class that implements the converter interface. We're going to implement the getAsObject and getAsString methods with our custom logic. Now, the getAsObject method converts the string or user input to an object type, whereas getAsString converts the object to a type string to send back to our view. Step 2 is to register the converter using either annotation or defining it in our faces config. So for the annotation, we've used the @faces_converter followed by the name of our phone converter. Or we could define this same setting in our faces config using the converter tag followed by the converter ID and the converter class. And finally, step 3 is to use our converter in our page. So we have an input text, and the child component is an fConverter tag with a converter ID corresponding to the name of our converter, which is phone converter. And that concludes our lecture on JSF converters. Our next exercise is on the JSF converters. The goal of this exercise is to change the data type of title from string to integer in order to let implicit conversion take place. We're going to also add a salary field and use a JSF converter to apply currency formatting to our input. Step 1 is to set up implicit integer-based conversion. In jobapplicant.java, we're going to change the data type of the title field from string to integer, and we're also going to have to update our getter and setter methods. So let's bring up our IDE, and we will navigate to the model package for jobapplicant.java, and we're going to change the title to a data type integer, and we'll also update our getter and setter methods. Step 2, we're going to add a salary property to, again, jobapplicant.java. It's going to be of type data type integer. So let's copy the instance variable along with its getter and setter methods. And going back to our IDE, we can place this right at the top here. Step 3 is to add the salary markup to our view. So in jobapplicant.xhtml, we're going to add the input text for salary below the country select one menu. Again, we have an output label, which corresponds to the input text. But most importantly, we have an fConvertNumber tag as a child of the input text with the following two attributes. The type is specified as currency, and it will only accept integer values. We're also going to output the server-side value below our form. So our first step here is to copy our markup and place that below the country in our jobapplicant.xhtml file. So we'll just scroll down and place that right below country. Secondly, we'll add our server output. And this again goes below country, but down here in our output section. Now, we can run the application, but there's going to be no change when interacting with the title field. Due to implicit conversion, title will now be saved as an integer on the server. So again, we're not going to see any change in behavior. So we can still select a title attribute, but we're going to let implicit conversion take place. Now, we're going to change the salary type to int in jobapplicant.java. We're then going to republish our application, and we're going to see that the salary is initialized to $0.00, and salary is going to be a primitive, and primitives cannot be null, so the int is initialized to 0, and the conversion is applied to 0, which is useful as it prompts the user to enter in a salary in the converted format. We should use primitive wrapper classes to have our fields initialized to blank values. So let's go and change the salary to type int in jobapplicant. So back to jobapplicant.java, and salary will no longer be a type integer, but now an int. And we'll have to modify our getters and setters as well. We'll then restart our server to ensure that all changes have been pushed across to our WAR file, our deployed WAR file. And we can refresh our page. And we can now see that the salary field is formatted. Step 6 is to test the convert number tag. So we're going to enter 100,000 in the salary field and submit the form. Now, since we specified a type of currency, this is going to result in JSF outputting the following conversion failure message. So 100,000 could not be understood as a currency value. We're then going to add a $ in front of the 100,000 and hit submit. And the salary field will be converted from 100,000 to a pattern of type currency. But the server output should show the server-side integer value 100,000. And our final test here is to enter 100,015 cents in the salary field and then hit submit. The integer only set to true attribute on our tag will result in the cents being truncated. So let's go back to our browser and we're going to enter in 100,000. So here's our error message. Now we're going to add a $ and hit submit again. We'll then see our correct formatting. And we're then going to add 15 cents, which are then truncated. And that concludes our exercise on JSF converters. We're now going to implement a custom converter in our application. The goal of this exercise is to capitalize our first name and last name inputs using a custom converter. Our first step is to create a converter class. It's going to reside in the converters package. It's going to be called word capitalization converter, and we're going to need to implement the converter interface. So let's go to our IDE, and we're going to right-click on the source package, and we'll select New Class. In order to get a base name for our package, I'm going to select Browse and then select org ICEfaces training applicant view and append on the converters package name. We're then going to call the converter word capitalization converter, and we're going to add the converter interface. Ajax faces convert converter. We'll then select finish. Again, we have our two stubbed methods, getAsObject, which will convert our user input of type string to an object, and also the getAsString method, which will convert an object to string. Step 2 is to annotate our class, so we're going to register this converter with the JSF framework by adding an @faces converter with the converter name annotation to our class, and this is going to register the converter with JSF under the name word capitalization. So we'll take this annotation and we'll place it above our class name. We can then hover over to resolve the missing import, so Ajax faces convert. Step 3 is to implement the converter methods. So we're going to call a fixed capitalization method on both the object and string when they are returned. So we'll just copy this piece of code here, and we're going to overwrite our existing getAsObject and getAsString stubbed methods. We have not yet added the fixed capitalization method, but we'll do that next. Now step 4, as I said, is to add the capitalization method. We're not going to discuss the logic, but simply paste the method into our class. We can paste that in below. Step 5 is to add our converter to our page components. So we're going to use the new converter by registering it with our first name and last name components. So again, we have our converter attribute, and we've specified to use the word capitalization converter. So we'll copy the first input text for first name, and we'll go to jobapplicant.xhtml, and we're going to overwrite our first name input text. We're going to do the same for the last name input text, and again they just include a converter attribute which corresponds to our word capitalization converter. And now we can run the application. We're going to enter in a lowercase name in the first name field, and we're going to again enter a lowercase name in the last name field. We will submit the form, and the word capitalization converter registered with the components will automatically capitalize the input. So let's go to our IDE, and I'm going to start my server. And then I'll bring up our application. So I'm going to specify a title, a lowercase first name and last name. I'll select a default country along with a salary, and then I'll submit. And we can see that, well, in our input components, the first and last name have been capitalized, along with the server-side values for first name and last name. And that concludes our exercise on creating a custom JSF converter.